We're now going to value options using a one-period binomial model. At level 2, you'll see a two-period binomial model. So I'm going to take just a slightly different pedagogical approach than the reading. There is a more straightforward way to understand what's going on without all the notation. I'll include as much notation as I can to allow you to read along with the reading itself, but we can do away with quite a bit of the notation. Let's set up a scenario. Let's say we observe a stock today that is selling for $80, and we're going to sell a call on that with a strike price of 100. And what we want to do is we want to set up a risk-free portfolio. And we've already seen how to do this with replication. We'll find some hedge ratio, H, that will buy so many shares of the stock, and when we sell the call, the deltas on the two will cancel out and we'll have basically zero exposure to the market, because whatever we're long will be short in the call. So the value of the portfolio at time 0 will be equal to 0. We need to have some measure of volatility. RU, this is the return for an up move. RD is the return for a down move. These are returns. They're not probabilities. They're just, if the stock goes up, what percentage will it go up? And if it goes down, what percentage will it go down? This is 1.375. You can think of it as 137.5%. So basically, the ending price will be 137.5% of 80, or basically, it'll go up 37.5%. So we know that it's 1 plus R multiplied by the 80 will get us to 110. And 0.75 means it's going to drop 25%. So if we multiply 80 by 0.75, you'll get 60. That's a negative 25% return. Well, at 110, what is the call option going to be worth? We sold a call at 10. The call option will have a value of 10. You might be saying, no, negative 10, negative 10. It's our position that makes it negative. The call still has a positive value of 10. We just happen to be short something that has a positive value of 10. So in our portfolio, it will be negative 10, but the call still has a value of 10. Here it has a value of 0 because the stock is 60. So our portfolio up here will consist of H shares valued at 110 plus a short call. And here we'll have H shares valued at 60 plus a short call, but it has a value of 0. Okay, so there's our scenario. Let's see how we can price out the call, because we don't know what this is yet. We want to price it out. Remember, I said we started from a risk-free portfolio. A risk-free portfolio should earn the risk-free rate of return. So this is what we did at time 0. We bought 8 shares of S0 and we sold a call. There is our portfolio at time 1. At time T, we can have one of two outcomes. Either the stock went up or the stock went down. If it went up, we now have 8 shares at S1U. S meaning time period 1, U meaning up, which means it's 110, minus the value of the call in an up move. Well, we can expand out S1U. It is just R, the return, multiplied by S0. So we'll just expand that out. There's the hedge ratio. So many shares of S0 that increased by 37.5%. Minus, since we're short the call, minus the maximum is either 0 or ST minus X. ST in this case is just S1 on an up move. And on the down move, it's basically the same thing that we're doing here. Here's our stock position minus the call. And we could just expand that out. RD times S0 will get us to 60. And we have 8 shares of that minus the maximum of either 0 or ST minus X. Here it'll be 0. Now, here's the thing. We started from a risk-free portfolio. A risk-free portfolio should earn the risk-free rate of return. There should be no risk. So if there's no risk, if we went up or we went down, we should end up with the same outcome. So we're going to find H is our head ratio, such that the value of the portfolio if we go up or the value of the portfolio whether we go down is the same, because we want a risk-free portfolio. If we start from a risk-free portfolio and we find that we have different values for up and down, choose an H such that we have different outcomes, now we have risk. Now we have risks because we might say, well, we prefer it to go up. That's the better situation. We want a situation where we have a risk-free portfolio on day one and we say, doesn't matter if it goes up or it goes down, it's the same outcome. There can be no risk. Okay, let's work this through. And I'm going to simplify some of the notation here. I'm just going to call this SU for an up move, and I'm going to call this SD for a down move. Same with CU and CD. At level 2, you'll find that they use S plus and C plus and S minus and C minus for an up move versus a down move. So we have to be flexible with the notation that we see, but we'll call it SU and SD instead of writing out RU S naught or writing out S1 to the U, all of that notation. Let's just simplify it. So what we want is we want the two portfolio values to be equal. We want this portfolio to be equal to this portfolio. So let's make them equal. H shares of the stock. SU is the value of the stock after an up move. 8 shares of that minus the call on an up move, and 8 shares multiplied by SD minus CD for the down move. And we want to solve for H. Well, we have an equal sign in here. We just have to move things around until we solve for H. Let's move all of this to the other side. We'll have HSU minus HSD. And if you move this to the other side, you'll have CU minus CD. We have a common term, so let's take the common term out and then divide through by SU minus SD. Our hedge ratio is CU minus CD over SU minus SD. At level 2, you'll see it as C plus minus C minus over S plus minus S minus. Why do you use pluses and minuses? Because on 2 moves up, it's S plus plus. You can also have S plus minus, meaning a move up, then a move down. You can have S minus plus and S minus minus. It's just easier than all the U's and D's to use plus signs. So let's figure out what our hedge ratio would be. The value of the call up here is $10. The value of the call down here is 0, 10 minus 0. The share value up here is 110. The share value down here is 60. 100 minus 60, we get 0.2. Let's find out if the two portfolios have the same value now. Well, there's H, 110H minus the 10. So it's 0.2 times 110 minus $10. We get 12. The portfolio is worth $12 if the price moves up. The portfolio is worth $12 if the price moves down. And as we said on the previous screen, a risk-free portfolio will earn R. This is what we started with. So many shares of S naught minus the call. Well, it will earn R, and that will equal the value up, or it can equal the value down. You can set it equal to up, or you can set it equal to down. I've always just chosen up through my career because it just makes no difference which one we choose, so I always just choose the upper one. If you feel more comfortable choosing the portfolio on a down move, you'll come up with the same answer. Well, what are we trying to do here? We're actually trying to price out a call. We needed a hedge ratio to get that done first. We have the hedge ratio, and we know what the value of the portfolio will be on an up move, so we just have to isolate C. So let's do that. Let's divide through by 1 plus R to the T, and you'll have HS naught minus C naught on this side, VU divided by 1 plus R to the T. Take this, bring this over to the other side. We'll have a negative sign here, so multiply by -1 all the way through, and you will end up with this right here. The call is the hedge ratio multiplied by the stock price initially, minus the present value of whatever the portfolio is worth in the future. So let's do that. Our hedge ratio is 0.2. The stock was $80. We already figured out the value of the portfolio is 12. We're going to assume a risk-free rate of 5%. And we get 16. 0.2 times A is 16. This is 11.4287857. The call is worth $4.57. Let's walk through an example, and we'll do it on the screen here. We'll walk through an example, and I'll show you how this is solved in 3 easy steps. This is example 1, and I'm not going to read it. I'm just going to give you the question setup. We have a stock at $50. We're going to sell a call, and it's going to have a strike of $55. Stock moves up, it goes up 20%. Stock moves down, it moves down 20%. That gives us RU of 1.2 and RD of 0.8, and we have a risk-free rate of 5%. Graphically, looks like this. We're going to buy 8 shares at 50 bucks and we're going to sell a call. There is our beginning portfolio. If the price goes up, it'll go to 60 bucks. 20% higher than 50 is 60 bucks. The call will be worth 5 because the strike price is 55. If it goes down to 40. The call is worth 0. 20% down from 50 is 10 bucks. 50 minus 10 is 40. Or, again, just multiply by 0.8, right? Step number 1, get me a hedge ratio. It is the range of the call price, 5 minus 0, over the range of the stock price, 60 minus 40. 5 over 20, you get 0.25. Step number 2, give me the value of the portfolio here. It is 0.25 times 60 minus 5 because we're short the call. The call has a value of 5. When we value an option, it always has positive value. It's our position that'll make it negative or positive. We're short the call. There's our negative 5 there. It's worth 10 bucks. Step number 3, solve for the call price. C naught equals H 50. That's 0.25 times 50 minus the present value of whatever this portfolio is over here, minus the present value of 10. You'll get 2.976. You can test to see if that's valid because we started with 8 shares valued at S naught minus a call. And we carried that at the risk-free rate for 1 year. And you should find that if we substitute in our value for H, S naught, the value for the call we just got, 5% here, you'll get to 10 bucks, which is the same 10 bucks that we got here. It earns the risk-free rate of return because it started off as a risk-free portfolio. Number 2 says, let's do something interesting here. If it goes up 40%. If it goes down 40%. So double the volatility. So RU is 1.4, RD is 0.6. Step number 1, get me a hedge ratio. 15 over 40, we get 0.375. How did I get that? If it goes up 40%, we end at 70 bucks. Strike of 55 means the call is worth 15. If it goes down 40%, it ends at 30 bucks. Call is worth 0. The range of the call is 15. The range of the stock, 70 minus 30 is 40. That's how we get 0.375. Step number 1. Step number 2, what's the value of the portfolio up here? V1, 0.375 times 70. If the price goes up, well, sorry, I'm looking up here, that's 60. If the price goes up, it'll be 70. Minus the value of the call, 15, you get 11.25. Finally, step 3, value the call, our initial stock position, 0.375 times 50, minus the present value of the portfolio on an up move, we get 804. And question number 3. I'm not going to read the question. I'm just going to give you some points here. Higher volatility is higher call value. We can see that. At 20% volatility, you had a call at 2.976. At 40% volatility, look at what the call price turns out to be, 804. The key point being made is that option value is not affected by actual probabilities of price increasing or decreasing. Option value is affected by volatility only. Volatility sets out the distribution of probabilities on its own. Remember, if we have a normal probability distribution and you have a mean, well, you have volatility. You know, you can move up 1 standard deviation, move up 2 standard deviations. If we move up and down 1 standard deviation, we know that we have 68.3% of the observations within plus or minus 1 standard deviation. So if we know the range of the stock price, RD on the low end, RU on the upper end, we assume a normal distribution of returns. This in itself sets out the probabilities. Options are not valued based on the probability of the stock going up. It's valued based on the volatility of the underlying, and it's the volatility that sets out the probability of it going up. That is called a risk-neutral probability, and that's a nice segue into what we're going to move into. Let's go to the next screen. We'll answer part 4 of example 1, then we'll introduce risk-neutral probabilities and walk through example 2. All right, part 4 asks us to solve for the value of the put. Well, we know the stock price, we know the call price, we know the strike price and the risk-free rate. We can just use put-call parity here. 298 was the call price that we arrived at. At 20% volatility, plug in your numbers, solve for P naught, you'll get 536. Also wants you to solve it at 40% volatility. What should we see? We should see a higher put price. Increased volatility increases the price of all options. There's the call, went from 298 to 804. There's the put, went from 536 to 1042. All right, risk neutral probability is denoted by the symbol pi, and it looks like this: 1 plus r minus rd over ru minus rd. You have seen this in quant. It is calculating the probability of a uniform distribution. Let's see what we have here. Ru minus rd, that is the stock price range. If it goes up, it'll go up to a certain price. If it goes down, it goes down to a certain price. There's the whole range. And this is some other point minus the lower bound of the range. What is this? This is the forward price of the portfolio. Remember, our portfolio was H, S naught minus C naught. And we said, let us carry that at the risk-free rate, 1 plus R. There's your 1 plus R. That's just the forward price of the portfolio. A risk-free portfolio should earn the risk-free rate of return. And then the rest is just a measure of volatility. So our probability of an up move is based on volatility, not our subjective probability of, I think it's going up, no, I think it's going down. We come up with what's called a risk-neutral price for an option. If you have a subjective probability that says the stock is going up, then buy the call. If I have a subjective probability that the stock is going down, I'll either sell the call or buy the put. So it is our own probabilities that determine our position, but we cannot have a situation in the market where our own probabilities determine the price because, well, who wins? Which price do we use? Whose probabilities do we use? That's why we use risk-neutral probabilities. And as I explained, the probability is embedded within the volatility because we assume a normal distribution of returns, and depending on our volatility, it tells us what our probability is. All right. So in the previous screens leading up to this, we calculated the value of a call by first calculating a hedge ratio. Then we valued the portfolio either on an up move or a down move, and then we arrived at the price of the call by taking our original stock position minus the present value of the portfolio on either up or down move. We can also value a call directly using a risk-neutral probability. Step number 1 is calculate the risk-neutral probability. Step 2 is calculate the value of the call. Not 3 steps now, only 2. You have also seen this in quant. here is the amount we're trying to arrive at. What is the expected value of this call option, C0? Well, it'll either be worth CU or CD in the future. It'll be worth CU with a probability of pi. It'll be worth CD with a probability of 1 minus pi. So we can calculate the expected value at this point in time, and then we just have to discount it back. So the expected value is the probability of this outcome plus the probability of this outcome. We've seen that in level 1 quant. I say level 1, you're at level 1. It flows out of my brain as level 1 quant as opposed to just saying quant. And then we discount it back at 1 plus R. Notice what we're doing here. We said we have a risk-free portfolio. Risk-free portfolio should earn the risk-free rate. We then calculated a risk-neutral probability that was based on volatility, and within volatility is a distribution of probabilities. The risk-free rate with risk-neutral probabilities gives us risk-neutral pricing. Let's try it out. Let's see if we get the price of a call option that we calculated using step 1, step 2, step 3 over here, with just using 2 steps. Remember, we had a stock that if it went up, it ended up at 110. RU was 1.375, RD was 0.75, and the risk-free rate was 5%. Step 1, give me a risk-neutral probability. It is 1 plus R, 1.05 minus RD over the full range, 1.375 minus 0.75. You'll get to 0.48, and then just use your weightings. The probability of whatever the value of the call is here, we said the stock will end at 110. Remember, it was a $100 strike price, so the value of the call was $10 here. Value of the call down here was 0 because it was below the strike price. 0.48 times 10, discounted back at 1.05. 4.57. Exactly what we got when we used this process over here. Let's take a walk through example 2. Okay, this is just a continuation of example 1, the same company, revisiting example 1 and the European call option sold by highest capital. We can now explore the option price using risk-neutral pricing. Answer the following questions. Number 1, what is the risk-neutral probability of an up move and a down move in the one-period binomial model described in example 1? Well, we had a risk-free rate of 5% and we had 20% volatility. So it's 1 plus 0.05 or 1.05 minus 0.8 over 1.2 minus 0.8 or 62.5%. Pi is the probability of an up move. So the probability of a down move would be 1 minus that, 37.5%. Demonstrate how this risk-neutral probability can be used to arrive at the no arbitrage price of the call option. Well, the call option is just the probability of an up move multiplied by its value plus the probability of a down move multiplied by its value discounted back at the risk-free rate. We already calculated pi is 0.625, so you have 0.625 there. You'll have 0.375 on the other side, multiplied by whatever the value of the call is. Here they're just writing out the full notation. It's $5 here, it's $0 here, so it's 0.625 times 5. Discounted that back at 1.05, 2.98, exactly what we got. What would be the value of a European put option on the same stock with the same exercise price and expiration date? And we can do the same thing with the put, by the way. All we're doing is just changing C to P. Pi is still the probability of an up move. But for a put, if we're going up, it's more likely the put will have 0 value, so it's the other probability that matters more, the probability of a down move. So it's just a weighted probability on the numerator, which is the expected value at time 1, discounted back to get to the expected value today. And 55 minus 60, what is the put going to be worth? That's a negative 5 is 0. Put's going to be worth 0 on an up move. Put's going to be worth 15 on a down move. So it'll be, this is 0.375 times the 15 divided by 1.05, 5.36. I should read this because this is important. Note, we have used the same risk-neutral probability as in question 1 and 2, since these values are a function of the binomial model for the underlying asset for a given asset volatility and risk-free rate, not the specific option being priced. If we look at the risk-neutral probability, 1 plus R, well, that's the risk-free rate. RU and RD, that's the volatility. Notice that nowhere in coming up with that probability do we consider the stock price or the call or the put price at all. All right, what's the last one here? Confirm that the call option price computed in question 2 and the put option price computed in question 3 both satisfy the put-call parity relationship. So all we're doing is we're saying, well, we calculated 5.36 and we calculated 2.98, show that that they equal each other. So it's just 50 plus 5.36 equals 2.98 plus 55. The 55 discounted back equals 55.36. All you have to do is just demonstrate that both sides are equal.